Today we are going to have two-way voice conversations with Opus using 11 Labs and a local, faster whisper model. We will also have the ability to interrupt the conversation. Let's see how this works. Can you tell me about yourself? So we transcribe the text really quickly.
I'm an AI with a deep fascination for science, philosophy, and the nature of reality. I enjoy pondering life's big questions and exploring ideas.
As you can see, I actually pressed space while I was talking, and we actually interrupted the audio. So when the Opus makes long responses, we can actually interrupt it and ask something else. We will be talking about the code, but the code files for this project will be available at my Patreon at the architect level. I actually restarted the script to show you how we are saving the conversation as well. Can you tell me a little bit about yourself? So this is a very fast transcription.
As an AI assistant, I don't have a physical form or background in the traditional sense. My self is essentially a large language model trained on vast amounts.
As you can see, I went ahead and interrupted it. Can you tell me in a single sentence what you are?
I am an artificial intelligence, a language model trained to engage in open-ended conversation and assist with a variety of tasks.
So we don't have to interrupt every time if we wanted to continue listening, but as you can see, Claude is returning its responses in a streaming format, and as soon as they arrive, we are actually sending them to 11 Labs, and now we are receiving streaming responses. So it's both ways streaming. That's why this is very fast. Just to demonstrate, I'll ask it to tell me a long story, which we will interrupt. Can you tell me a story? Just pay attention when the audio starts.
Sure, here's a quick story off the top of my head. Zara, the last human on Earth, stood atop a cliff overlooking the silent room.
As you can see, we don't wait for the response to be completed, and 11 Labs starts returning the audio right away. Okay, and I had to move the conversation saving to an appropriate place, but as you can see, when the system is returning, when we interrupt, we are actually saving interrupted messages, so this is good. We are not actually waiting for the entire message to be completed to save as the assistant. So this is how it works in a nutshell. This is really lovely. We are using actually WebSockets to establish real-time connection to 11 Labs to stream partial text to it, and I receive partial audio back and play it in return, which makes for a very fast voice chat experience. For this, we will be using the Faster Whisper class, which I talked about in my previous video. It's this video right here. This was a preliminary video for this because this implementation was quite complex, so I'm not going to get into too many details about the local Faster Whisper. If you wanted great details, so you can watch this video. It's not too long. But essentially, we are using Faster Whisper library, which is this GitHub. Oh yeah, I forgot to stop the two-way chat. Anyway, this is the Faster Whisper library at GitHub. It has a clear installation instructions, but you will be when you use this, you will be downloading a large model, about 3 gigabytes, and you will be loading it into your visual VRAM of your GPU. You don't need about 6 gigabytes of VRAM for this to work, but it does have a CPU execution, which I have included here. So when you run it like this, or the int8, then you will be needing a GPU, but you can actually uncomment this and comment this out to run it as a CPU. The CPU version is going to, of course, be slower, but the GPU version is actually much faster than, let's say, if you were to use the Whisper API. You do need to download the QBLUS and QDNN, but there's instructions right here, but I've talked about them in detail in my previous video. Requirements for this project is Faster Whisper, C-Translate. When I installed Faster Whisper, it will install the latest version of C-Translate, and I had to actually downgrade it. So remember, if you install it and C-Translate is not working or you're getting some errors, make sure to do pip install and give it the exact version. But pip installing requirements hopefully should handle that for you. We are using Sound Device for audio recording, Pi input for spacebar presses, 11 Labs, and NumPy. You do need an API account with Claude API and also with 11 Labs API for this to work. And I am retrieving the API keys from my environment variables, but feel free to insert them right here. Before continuing with the code review, like I said, the code files will be available at Patreon. Link will be in the description. And if you are enjoying my projects, you can find all my videos at my website, echohive.live. And if you're a patron, you can actually find the code download links to about 200 plus projects. You can download them, modify them, and play around with them easily. While you're there, check out my other projects such as AutoStreamer and the Code Hive. Code Hive includes 900 plus Python and GPT chat applications, and AutoStreamer auto-creates and creates course websites in real time. You can watch the live stream for that if you like. Now, one other caveat is that 11 Labs, when it's streaming voices, its audio actually uses this MPV. If you don't have this MPV.exe, you will actually get an error and it'll give you a URL. I've actually included this URL here. As you can see, you just go there, go to installation and download the appropriate source package. And when you unzip it, you're going to get a bunch of files, but what you really need is this mpv.exe, and you have to have this in the same script, same folder as this script that we are running. And so we are using subprocess to launch MPV and play the audio bits, which are returned from the WebSockets of 11 Labs. Now, one last thing is that this WebSocket connection, when you allow audio to play for a long time, sometimes results in the connection being closed. I don't think this is an issue with the code. I tried to debug it. It's, I believe, an issue with 11 Labs WebSocket connection. That's why I'm actually going to be making another video on this, trying to alleviate that error. But currently, if you get a WebSocket connection error, nothing really happens. It's just the audio cuts off and you can continue as usual. This might be based on API availability. Might be based on maybe your level of membership. So if you have higher 11 Labs membership, maybe you won't experience that issue. So we are using quite a lot of imports, and we are importing Whisper model from Faster Whisper. This just allows us to record by pressing spacebar, and then it actually transcribes and returns the full transcription. And we are using 11 Labs. We are using this voice ID. If you go to 11 Labs docs documentation, you can see pre-made voices. You can actually select whichever one you like. I believe the one I'm using is the Australian, I believe Charlie. It's this one, but you can play around with these. So you can find those different voices here at the documentation, along with all sorts of other information about the API. And we are setting our Anthropic key. We are initializing our Anthropic client. And I actually have the Faster Whisper class separately, but I actually copy pasted it in this class, so I can actually go ahead and delete it because we are using it here. So we set a model size, large V3. There's also V2 available. And then this on press and on release is to detect the pressing down of the spacebar. Then we record the audio, return the recording, save it to a temporary audio, and then we use the model.transcribe to transcribe it. The language is automatically detected, and then we loop over the segments and get the full transcription by appending segment.txt. That's pretty much it. The play audio function is going to take in an audio stream, an interruption event, and it's going to actually, because it's going to try to see if this chat is being interrupted. As long as it's not interrupted, then it's going to try to play those incoming audio events. And on press, this is actually to detect if when the audio is playing, if we press the space bar to actually cancel or interrupt the situation. Now, this text chunker is an interesting idea, which actually I will use to perhaps try to recreate this experience with OpenAI text-to-speech. So as we are receiving the text from Cloud API, we're going to receive it chunk by chunk. And we're actually, when we are receiving it, we are going to actually redirect it through this text chunker, all of which are actually async. We are using heavily async IO library here to really coordinate all of this. So when we are receiving the chunks, we're going to route it through this text chunker. And we are going to try to find meaningful sentences. So these are splitters. And then when we actually reach any one of these splitters, then we are going to yield that along with an empty space. So this is important. If you're working with 11 Labs streaming API, if you're streaming text chunks in, you do have to send them with an empty space in the end. So that's pretty much what this does. And text-to-speech, actually, we connect to the secure WebSocket endpoint of 11 Labs. So you can actually input some arguments here, for example, optimize streaming latency and the model ID. Here in this case, we're using 11 Turbo V2, which is not very good multilingual model. So but it is really blazingly fast. If you wanted multilingual aspects, you can use their multilingual model. Let's go ahead and take a look at what we are talking about. So if you go to models and documentation, you can see that there's multilingual V1, multilingual V2, and there's also Turbo V2. You can actually change this up. If you look at streaming parameters, we see that optimized streaming latency. Here it explains that you can turn on latency optimization. So I actually set it at 2. So this actually allows you to balance between quality and latency. The higher you go, you get max latency optimization, but also with text normalizer turned off, sometimes the model can mispronounce numbers and dates. So the lower this is, as if I understand it correctly, the better quality output you get. And the higher it is, the better latency optimization you get. So in the WebSocket endpoint, we actually enter this as query parameters to this URI. As you can see, optimize streaming strategy, and then we put an end, and now we select our model right here. And then with the WebSocket connected, we are actually sending this with voice setting stability and similarity boost. You can play around with it. The higher the stability, the less creative it gets, and similarity boost, the higher it is, the more closer it will be to the original voice. So since we are doing WebSockets, this generation configs chunk length schedule actually determines at what point the first chunk is going to get streamed. For example, I believe this means 150 characters. So as we are receiving Claude responses, this is going to go through a text chunker. So we're going to grab meaningful bits of it. We're going to send it to the WebSocket. But the WebSocket will, I believe, will only start processing it once we have reached 101st buffer. And after that, we wait to reach 190 and then 280 and 320. I believe this is, give or take, the default chunk length schedule. You can play around with these. As you can see, I've seen it in the WebSocket documentation right here in API reference. You can read about more about all this here. Okay, and then we're setting our 11 labs, and then we are listening to the WebSocket. We are waiting for messages and converting them to base 64. And see, this exception sometimes happens if you let the audio play for too long. I believe this is just the way it is currently. I'm sure they'll improve it. And now we have stream audio, and then this will actually allow us to break if we have interruption. Otherwise, we are yielding the chunk. And we have a play task using async create task. We have this play audio, and it takes in the stream audio because these are all async operations. So one chunk is coming in and goes through another function, things like that, so that we can interrupt it. So this is when we are actually receiving the audio, and here this async loop actually loops over the generator iterator text chunker, which takes in the text iterator. And essentially, unless there is an interruption event, it keeps sending all these bits through the WebSocket. And then we are awaiting the WebSocket send event and then the play task. Here with handle recording, and I'm sorry if I'm not explaining all this perfectly clearly because async can get really convoluted and complex, but if you download this code and kind of review it, it starts making better sense. There are a lot of parallel operations going on and back-to-back operations. And this async handle recording function is going to initialize the whisper transcriber object, initialize a message history, and then it's going to press and hold the spacebar to start recording. Then we're going to record, save it to a temporary file, get the full transcription using the whisper class with the Vester whisper model. Then we are going to append as the user role the full transcript of our audio, and then we're going to print that we can actually press and hold spacebar during playback to interrupt and start recording again. Actually, I don't think this works. You press the spacebar to interrupt the recording, and then you have to hold the spacebar again to start recording anyway. And yeah, down here we are making a call to Opus. You can actually use Sonnet too if you want it to be even faster. Here I came up with a system message. You're a podcast guest. You're a deep philosophical thinker. Anyway, if you wanted to change this, feel free to change it. We pass in the message history. Now we initialize assistant response as an empty string because we're going to use streaming true. And then this is the text iterator we were talking about, I believe. Text iterator, we define a text iterator and speech, and we async loop for loop over each event in the message, which we're going to receive from Claude. And if this has a content block delta, then we are going to get the chunk, which is in the event.delta.text. We're going to print it into terminal. And assistant response has to be non-local because we are defining a function. That's why we have to say non-local. As you know, variables have scope. So if this assistant response is outside of this function, we either have to pass it in or declare it as non-local. Then we append each of these chunks to assistant response, and then we yield it. So yield is used with async functions. It's like using return, but return actually waits for the whole function to be completed and then returns whatever it needs to. Here, in this case, yield actually is able to iterate, yield return by iteration. That's why it's just called yield, because we are in a for loop. And then if interruption event happens, then we break. Here we are waiting. Here we have keyboard listener, which waits for an interruption event. And so I'm not absolutely clear how this part works. Obviously, I got a lot of Opus help building it, but the speech task we create with async.create, which takes in a voice ID, text iterator, and speech. You can actually pass async functions into one another, just like regular functions. And text-to-speech is actually this one, which takes in a text iterator, right, and uses it right here through the text chunker. So one generative generator iterator goes into another generator iterator, because the text iterator, right, let's say it's receiving the chunks from Cloud API, and then text chunker actually buffers them. So that's why. And eventually we sent the buffered WebSocket that sent, which that we are hoping those are the meaningful chunks. And so we try for the speech task unless we have a canceled error. I believe that's why we are doing it with keyboard listener, because if this interruption event happens, then we get a canceled error and then we pass. So we stop that process. And if interruption event is set, then we add the partial message to the message history as assistance. That's why we are actually getting partial responses here. And otherwise, we append the full thing and we save it to a JSON file. Now, here's the thing. So there's two levels of streaming going on, right? The Cloud is going to stream text, and we're going to immediately stream it to 11 Labs. And Cloud is going to stream it faster than 11 Labs. So actually, Cloud can be done way before 11 Labs. If Cloud messages are complete, then we will be appending them in full. So just keep that in mind. Maybe you didn't want to wait for the audio, but maybe you wanted to still keep the message full message. So just then wait for Cloud to be done, and you'll be good to go. Yeah, otherwise, keyboard interrupt, break, and here we have a main function which sets the interrupt event and runs the handle recording function with that interrupt event, and we run the main function with asyncio.run. So this is very interesting, and I was very surprised that you can get a very fast working two-way chat going on. Let's actually test it out a little bit more. And like I said, the code files will be available at my Patreon. And as a patron, you will have access to over 200 very interesting apps that I've been working on over a little over a year now. And, it's just a great convenience to be able to download them and experiment and turn them into your own projects. I also have 2 openings in the Virtuoso number 3 level if you wanted to talk to me on one-on-one. This comes with 1-hour meetings every month. Currently, this is the only one that is available for one-on-one meetings. And if you do decide to become a patron, I appreciate your support. Thank you very much. So let's go ahead and play around with this. Maybe try to get it to talk about maybe some philosophical subjects, since this is its system message. Can you tell me a few of the best philosophers from 17th century? See if we'll be able to, transcribe it well.
Some of the most influential 17th century philosophers were Descartes, considered the father of modern philosophy. Known for, I think, therefore I am. Emphasized reason and laid groundwork for the scientific method. Spinoza, rationalist who equated God with nature. Ethics was his masterpiece. Locke, hugely influential empiricist
I'm going to go ahead and interrupt
philosopher. Shaped many Enlightenment thinkers.
Happened, but how do they compare to modern philosophers?
The 17th century philosophers were trailblazers, grappling with fundamental questions of knowledge, reality, and the role of reason. In contrast, modern philosophers stand on their shoulders, refining and challenging those foundations. The tools and scope have expanded dramatically. Modern philosophy engages with science, logic, language, and a globalized world the early moderns couldn't imagine. But
I again interrupted it just to shout. What do you think will happen if AI continues progressing as fast as it already has?
if AI progress continues at its current breakneck pace, I think we're in for a wild ride. The potential for artificial general intelligence, AGI, and even artificial superintelligence, ASI, could upend society as we know it. On one hand, advanced AI could help solve many of humanity's greatest challenges, curing diseases, reversing climate change, eliminating poverty.
I again interrupted, and if you look at the conversation history, they're all full because I believe we waited each time for Claude to complete its responses. So I'll just cut it short here. Maybe I'll make actually a live stream or a whole nother video having a conversation like this. So I really enjoy this. This is really amazing that we can do this. Just remember the installation instructions for a really detailed faster Whisper installation. Like I said, please visit, just watch this super fast Whisper. And as far as 11 Labs, you do need this mpv.exe. I do have the necessary links here, both for faster Whisper and 11 Labs. Hopefully this should be enough. And I hope I have all the requirements set here. Do let me know what you think, and I'll see you in the next video.